Hello, viewers. In this virtual class, we're going to look at this integral before us. It's a show that integral 1 minus tan square x divide 1 plus tan square x ds is equal to half sine 2x plus an arbitrary constant c. Okay, in this equation, the question before us, we're going to make use of substitution. We're going to make use of the fact that tan is sine over cos. So here, tan x, the expression for it is the ratio of sine all over cosine. So that is sin s over cos s. So we will replace, in place of tan x, we'll replace it with sin x divided by cos s. But recall that we're having square here. So definitely, this become integral 1 minus sine square x over cos square x divide 1 plus sine square x divide cos square x. Okay, let us simplify this first, then we put all our integral sign. Here we make use of we simplify all this, simplify it. They are fractions already, so we need to simplify this. Here the LCM of this fraction at the numerator is cos x, so we'll write this. This is cos square x. So cos square x divide 1 is cos square x, multiply 1, that will give us cos square x minus cos square s divide cos square s, that is 1 times sine square x, that becomes sine square x. Okay, we come to the denominator of this, which is this part. Then the LCM there is also cos square x. Cos square x divide 1 is cos square x, multiply 1, that will give us cos square x plus cos square s divide cos square s, that will give us 1 times sine square x, that becomes sine square x. Here we use the fact that far by far and near by near. So here this expression means we are saying this divide by this, and well, we say this divide by this, naturally we change this division sign to multiplication by inverting the denominator of this fraction. So okay, here this one simply means cos square x. Okay, so this simply means cos square x minus sine square x into times cos square x, that is far by far, near by near. Okay, here we have cos square x plus sine square x into cos square x. You see this is off. You also recall that cos square x plus sine square x is equal to 1 from trigonometry. Okay, here. So what is left here now is just we are left with only cos square x minus sine square x. But if you recall from trigonometry, if we have cos, for instance, cos x plus y is cos x cos y minus sine x sine y. But if we say s is equal to y, so that means equal angle. Okay, here this become cos 2x, s plus s is 2s, so here become cos square x minus sine square x. So if a is equal to, or y is equal to x, so if we will use this fact, you know, to find an expression for this cos square s minus sine square s is the same thing as this expression here. So all our expression here has been reduced to integral has been reduced to cos 2x ds. Okay, that is now our expression. So our expression is now cos 2x dx. From here we can easily forge ahead by using integration by algebra substitution. Okay, here we say let u is equal to 2x. We're going to look for an expression in terms of the s from here. So by so doing, what we do is we differentiate this become the u over the x. If we differentiate this 2x, it just become 2x. It just become 2. Okay, it becomes just 2. And the next step here is we make this ds subject of the relation by multiplying both sides by the x first. Here we say this is the x. This will be off, so that we have the u is equal to 2 dx. We want to make only the s subject to the formula, so we divide both sides by 2, so that dx is equals to the u all over 2 divided by 2. So we will replace in place of dx in this expression, we'll replace it with the u over 2. So that means our expression is now reduced to integral of cos u, because we've already said that let s is equal to 2x is equal to u, or u is equal to 2s. So here in place of the s is now the u over 2, the u over 2. Okay, then we factor out this half here, this become this integral become 1 over 2 integral of cos u du. And it's very easy for us to find the integral of u of cos u du. So if we integrate cos, our answer will eventually become sine u. So our integral here, this become 1 over 2 sine u plus arbitrary constant. Okay, now what next? Because we said that let u is equal to 2s, we substitute the value of u in this place, and this become integral become half sine 2x plus the arbitrary constant. So, and that means we'll be able to show that this integral is equal to half sine 2x plus an arbitrary constant. Okay, this is how to, you know, to maneuver this kind of integral function. Okay, all you help me to do, help me also subscribe to my YouTube channel. Help me promote this channel, and hit the subscribe button, and also hit the notification button. When a similar video like this come up, you will be able to have access to it. Have a nice time. See you in my next virtual class.